Stop it. Don't do that. Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 97. We love MicroMice. We're looking into the case of the missing drones, and 3D prints are being tested for both Rocketry and food prep.
What you been up to this weekend, Mike?
Not a ton of stuff. I did some more on that assembler for the badge, and that's going pretty well. And I think I'm probably the very last person to fully embrace VS Code as an ID, and that's been pretty nice and fun lately. How about you?
I spent a little bit of time this weekend revamping my hot wire foam cutter, which is kind of fun. Let's see, for those of you who don't know, a hot wire foam cutter is, well, it heats up a wire and you run that through styrofoam or other hard foams and make cool things out of them. I've been making airplane wings out of mine, but I need to step it up a little bit. And that means for me going from a 3-axis machine where the wire is held on two sides by essentially XY bots. And mine only does 3 axes because of limitations with the driver. So they lift the string up and then backwards and forwards, but the two towers have to lift the string up the same amount. And that means it can only make kind of certain symmetric wing shapes. And I want to make some funny asymmetric swept wing things. So I'm looking into making a 4-axis machine out of it. And all of the gerbils I've found, and that is the GRBL CNC driver, are all 3-axis, or at least getting a 3-axis gerbil setup is super darn easy, and moving to 4 requires a lot more work somehow.
So right now you can do forward, backward, up, and down. What's the 3rd axis?
What I want to do is 2 separate 2-dimensional axes. So each one
So you
can go
do
forward, backward, up, down, and then the other pillar can go forward, backward, up, down. So you can not just kind of raise and move the wire through the thing, but you can also tilt it.
Yeah, so like right now you can pivot kind of like turning a piece of paper on your desk.
Mm-hmm.
And you want to add that pivot to the, like if you had a piece of paper on the wall, you want to add a pivot in that dimension.
Right now there's one way I can pivot, and I want to be able to pivot 2 ways simultaneously.
Right. That is confusing to think about.
Slanted on this way and slanted on that way.
What's the firmware like for that? Are you writing it, or do you have
No, I'm just using Gerbils GRBL straight out of the box. So piece of cake, and then that just takes G-code, so you can send it whatever you want.
Yeah, well, I'm just wondering calculating those geometries that you need to end up in G-code. How do you do that?
Oh, it's actually dead easy. Most of these wing shapes are really just you take a known airfoil and you cut it out. And the known airfoils are all stored in a kind of normalized data file format.
Oh.
And actually it's like a 10-line Python script that I wrote myself that actually makes the code that feeds these things. There are significantly fancier programs out there that are probably better. Like one of the things that you need to worry about with a hot wire cutter is that it cuts by melting the foam. And so there's kind of a, 1 millimeter zone around the wire as it's moving through that melts. And you probably want to take this 1 millimeter kerf into account when cutting the wings. And it's worse than that because it gets bigger the slower it goes. So if you have one side of the machine moving quickly, it has a thinner kerf than a part of the machine that's moving slower, which has a bigger kerf. So there's a lot of clever calculations you can do in there if you really care about the machine planning. But so far it's worked with just the minimum necessary. We'll see what happens. When I get a 4th axis up and running, I may have to push the software side a lot further.
Nice. Can we get some photos up? Do you have a project page somewhere?
I don't know. It's in my basement, and I'm entirely happy with it in my basement at the moment.
It's a very personal project, not to be shared.
I think it's, I think when it's into a state that I can take some pictures and stuff, I'll do that. I also kind of designed it with some old parts. I had a wall plotter, and I just basically stole the mechanisms from that, and they may be a little bit under-spec'd, not quite rigid enough to do the job that's being required of them. So it probably needs a redesign before it's interesting for anyone to look at. But I've been thinking about that actually, and I think I'm going to take some photos of it and document it in its current state so that I can say, here's why you don't do this, and here's why you don't do that. And when I make an improved version, I can say, yeah, so this is why I improved it this way. Because that stuff is good to know too, I think.
Oh yeah, those cautionary tales save tons of time if you can find them. Someone else has already made the mistakes.
Yeah, and if you look at a lot of the hot wire machines out there, I think they're incredibly over designed because the actual stress on the machine is very little. Because, like I said, it's this wire that doesn't even contact the foam. The machine has to just basically precisely move something very lightweight with no resistance at all. So it's a very different problem from like a mill, which has to take incredible side loads, or even a 3D printer, which has to take some side loads, have a little bit of inertia, but just move really, really quickly. A wire cutter needs to move slowly because it needs to like slowly work its way incrementally through this foam. So it's a really easy machine problem, and most of the machines I see out there look really overbuilt to me. So I kind of tried to go the other way and underbuild, and I think I went too far and underbuilt. Want to talk about some other people's hacks?
Yeah, let's talk about some good hacks we saw on Hackaday this week. The first one that I picked is an epic quest for a motorized volume knob. Harris Andrianakis wanted to add some automation to the volume control on a Logitech computer speakers and ended up kind of going down the rabbit hole. The reason I like this one so much is that they're showing off every iteration of the project, and like all good projects, it failed several times along the way. So the first one was just adding a servo motor directly to the knob on the back of it, but the problem is those geared little hobby servos are not all that easy to turn, so you kind of lose the manual, functionality of the knob. Interestingly, a second iteration of it tried to use the same servo but with like a belt-driven approach to it. And that makes it so you can still turn the knob because it'll just slip on the belt. But that also meant that the belt slipped when the servo turned, and it wasn't like, I don't know if you can really zero these out. And so it makes it difficult for you to, if you're dead reckoning on the volume, for one thing, but it just seemed to not work reliably. The final version ended up mounting a stepper motor, and the stepper motor did the trick along with some clever gearing to pull it all together.
Yeah, that's a really good solution for this. I'm looking through it right now. First thing you might try is to use a servo like that, but if you have to turn that knob yourself, that's already a no-go because those things have kind of fragile gear trains, especially these like dirt cheap ones. And if you back drive them a lot, that really reduces their life. Yeah, if he's turning that manually, especially one of these, I mean, these things cost like 28 cents each. He's going to break that thing and be sad about it. So a stepper is definitely the way to go. Although with the stepper, you lose absolute position, right?
I don't remember reading that. There must be some kind of way to zero it so you know where you are. I mean, that's another thing I was thinking about. This is an excellent project to take on if you're working on mechanical design. And it's nice that there's enough room inside of the housing of this speaker. Usually there's not much inside of these speakers. It doesn't take much to drive a speaker, but they tend to have some volume inside of them to make the acoustics of the speaker work well. And so that's being used here to hide away the motors. But I thought, like, how would you do this if you didn't want to put motors in it? And I think you'd kind of like man in the middle it, right? You'd get some kind of like digital potentiometer and you'd put it on the input to the circuit, and then you would just monitor the original volume. And so you could change it programmatically, but the thing you lose is when you change it programmatically, then you're not actually turning the user input either. So it gets a little hairy there. I think this is probably the most elegant solution. I do have to say, wonderful documentation on this one. It's got great pictures of the inside and like the mounting bracket for this. I think this one is going to work for the long haul, which is something I was worried about with my own projects. Like, okay, if I get it working once, am I going to remember how to fix it when it breaks? I think this one's not going to have that problem.
My next hack this week is also a cute machine build. This automated wire prep machine cuts and strips the wire. This is a build by Mr. Innovative, who's been giving us a couple interesting YouTube machine builds lately. This one has 2 stepper motors and a servo, and it runs a pair of those wire strippers, the ones where you can use a little screwdriver to adjust the gap, and you can either cut or strip with them. And that's what I find most charming about this machine, in fact, is that he uses them to both cut the end of the wire off and then strip the insulation a little bit with the little like diamond-shaped strippy hole. And the coolest thing is that he switches between these two with a little servo motor. So the wire is guided into the stripper through, I don't know, looks like a Teflon tube or something, a little piece of tubing. This tubing is zip tied to a servo motor, and the servo just points it at either the part of the jaws of the stripper that has the insulation cutting part, or the part of the jaws of the stripper that snips it off at the end. The rest of this build is actually kind of stuff we've seen before in hobbyist wire strippers. The feeder is basically a filament feeder off of a 3D printer. In this case, he 3D printed it all himself, so it's a completely homemade filament feeder, but it's a filament feeder. And the mechanism closing the strippers is just a servo motor and a wheel. So in some sense, it's simplicity itself, but in other ways, it's like these little touches that make it work beautifully.
I like those little bypass strippers like that, though, too. They do a good job of cutting, so it's nice to recognize that that tool is the perfect one for this job. I love it, so don't get me wrong, but I'm going to be critical for a second. I was a little bit disappointed that it didn't remove the insulation that it clips.
Yeah, some people said that in the comments, too. I have to say, when I get wires, if it's part of a kit or something that you're shipping, I would rather have the insulation left on it, because if you strip it off ahead of time, in shipping it gets damaged. It gets banged, mangled. The threads of the internal cable come all undone. This way, when you're ready to tin it, you just go ploop, pull it off with your fingers, tin it, done.
Touché.
Keeps the interior cable in place.
Yeah. No, I'll give you that. That is a good point.
The other thing that really struck me about this is his nice front panel, and he didn't document it particularly well, and so I went digging. It's actually kind of neat. It's a panel with an integrated GUI software made by Nextion, and I'll throw links in here for you people. It's actually about 4 years old. I'm surprised we don't see these in more projects. I guess it's because it's a little bit expensive. It's got an incredibly high-powered microprocessor on it and this whole GUI building widget library and stuff. And so the brains of this operation is actually a little STM-103 blue pill board, and it speaks over serial to the little computer that's attached to the LCD screen that does all the GUI magic. Like you're sending over the serial terminal, give me a push button here or make this kind of graphic there. And the graphics are all stored on the little computer that's attached to the backpack on the LCD screen. It's kind of neat stuff, but it's a little bit expensive. I mean, they're kind of $12-15 single quantity. But what this thing does is it just totally reduces the software development cost. And it makes me think, why don't we see a do-it-yourself equivalent of this? Is there a good GUI library out there that people use for microcontroller applications? And then if there is, can you flash it into a second microcontroller that you can bundle up with your LCD so that controlling that is even easier?
Or like an open source, like you send it some JSON file over serial from your main microcontroller, and that shows what's going to be on the display. That's interesting.
Yeah, I think it's kind of a neat approach to kind of disentangle the GUI/human interface stuff from the program logic, from the business logic of whatever device you're making. And, if you look at this one, it has a little animation when it's running, and it has a beautiful graph showing, how much you want to clip off of each end and how long you want the wires to be and stuff. Just the human factors look like they're really well thought through here.
The next one on my list just really struck me by how accessible physics experimentation is to us right now. This is SLA 3D printed vortex cooled rocket engine. Danny Conradi wrote this one up on a video from Sam Rogers, and it shows a translucent, almost transparent, 3D printed part that is the combustion chamber and the nozzle for a rocket. And the question that comes to mind immediately and is answered immediately is, how is it possible that you could 3D print something and not have it immediately melt into slag when you light the rocket? And the answer is that it's using thermoplastic resin, which is a specialized material. In this case, it's really interesting to hear the walkthrough of a vortex engine using oxygen injected kind of along the walls of the combustion chamber. to create like a little tornado inside of there that goes towards the back of the chamber, what would be the front, the nose of the rocket. And then it wraps around, mixes with the catalyst, and comes down the center where it's ignited and comes out the nozzle of the rocket. And the reason that they do that is that vortex of oxygen on the way in is like a heat buffer so that you don't melt the sides of it. And so the only real heat problem for you is on the nozzle. And in this case, the whole thing is mounted on a rig that's measuring the force that's being put out at it. So they know that they're going to melt these nozzles, but it's really cheap and quick to print them and try the different nozzle designs and even try the different chamber designs until you get the kind of thrust that you're looking for.
And what's really cool about this is that their end goal is also 3D printing, but 3D printed into metal. And so this is the prototype for, a rocket engine that will last longer because it's going to be made out of metal, but they want to iterate quickly on the design and get all the funny vortex physics right and get it spinning just right inside there. And it's tremendously interesting to see them trying to get this difficult, like fluid dynamics mechanism thing working using transparent filament. You can see it swirling around on the inside, and I'm sure that gives them a lot of insight. And then at the end of the day, what have they got? They've got the 3D model that they're just going to send off to some laser sintering metal 3D printing place and say, okay, we've worked on our design, we've fixed it up, make this for us.
At some point in the video, they inject propane in it as an example that you have to watch out that you don't get the thing too cold because it'll become brittle. And when they light it, the nozzle blows up, and then it's just spewing flames and fire out onto the rails of the test apparatus. I'm like, oh no, they're going to build out their test apparatus. But I think it's a pretty quick demonstration, and so that stuff kind of holds up to it. But it does, the ability to put this stuff together, to iterate on it, to do it in the lab in a controlled environment before you start investing the really big bucks for the manufacturing, it does show you the power of these tools that have stood up. And they're available to almost everyone. I mean, they're pretty approachable for anyone to use, and I think that has great power.
So if you can make rocket engines by 3D printing, what can't you make? The answer is a cup. This next hack is actually kind of a science study, food safe printing techniques by Jakob of Prusa Labs. The internet is full of people who want to make like utensils and plates and cups and things to do with food out of 3D printing materials. And the kind of obvious problem here is that when they lay down in layers, there's little cracks in there that you can't get into. And 3D printed thermoplastics are hard to clean, and you can't get them hot enough to clean them right. And if you can't get in all the nooks and crannies, maybe that's a bad thing. And a lot of people have said this is a bad thing, and a lot of people have thought about doing it anyway, and this one puts it to a little bit of the scientific test. They take a couple cups, they leave one untreated as the control, they smooth one of them using chloroform, because that melts PLA a little bit. Not something I would do. And then they cover a third one in a light epoxy resin, and they put some milk in them, and then they swab them down later, and they culture up what they get out of the swab. To their great credit, they also do a negative control where they just take one of their cotton swabs and culture that up to see what happens if they don't do anything. This serves as like a test of how clean their laboratory conditions are. And then they do a positive control where they just dip the thing in milk and swab it around on their petri dish and see what grows out of that. And, this isn't real science. This is N of 1 science. We tried each one of these once.
One time, yeah.
And the results aren't actually super compelling. They don't get all that much crud out of any of them, but it also kind of runs along with what you'd expect, which is like the epoxy resin coated one, which should be honestly food safe, ends up not having any milk residue on the inside of it. Whereas the one that's untreated, they do manage to get some out. I don't really know what to think of this. First, what do you think about 3D printed food stuff?
I'm not a huge fan of plastic food stuff in general, right? I think we use plastic food storage in the refrigerator, but, I generally don't eat out of it, and we definitely don't, microwave anything in plastics.
It's definitely good for kids because they can't break stuff.
Oh,
But
touche. We do have those for the kids' plates and bowls. Although I think we're off of those now. We're on to metal cutlery and regular plates. I think
yeah, fair
cups
enough.
cups still, because cups get knocked over. So
Yeah.
we do have plastic cups.
Yeah, but I don't like plastic either. And I actually come from the old enough part of the Rep Rap community where we used to 3D print inaugural shot glasses as the first object out of a home built 3D printer. This used to be a tradition, and you can imagine pouring alcohol into there, solubilizing whatever bullshit you've got inside the shot glass, and then drinking it. Is that a good idea? Probably not. Probably not at all a good idea. I just don't think it's a good idea to 3D print cups or mugs, not because I'm worried about bacteria. Frankly, if I'm drinking milk out of it and a little bit of lactobacillus grows in it, meh. It's not dangerous. It might taste like curdled milk, but I eat yogurt too, right?
Yeah.
It doesn't concern me in a health way
Right.
in the least. It's just it feels tacky in your hands. I don't know what to say. I wouldn't do it anyway, but it's nice to see that they've looked through this. And I guess I do totally believe their result that covering it in a thin coat of epoxy resin is the way to go if you absolutely insist. And some of the cups look pretty snazzy. I mean, you can make kind of arbitrarily cool shapes. So I guess that's kind of cool too.
The epoxy resin does look almost like a glaze, so it
Yeah,
gives it a
exactly.
little bit more of that, like, this isn't a piece of junk sort of look.
Yeah, totally.
I don't know if that's the right way to describe it, but it looks a little bit more. I mean, as soon as you pick it up, the illusion's going to be gone, right? Because it's not going to have the weight of stoneware. But it looks pretty good with the epoxy resin on it, and if you're looking for something that you can wash over and over again, that should hold up to it.
And someone came in the comments and said, what you really need is a 3D printed clay printer or a 3D printed ceramic printer. And then, glaze it yourself. And then it's a really nice coffee mug that you've also made in this kind of arbitrary 3D printed cool shape way. And I'm totally down with that, although I'm not sure I'm going to go that far myself.
All right, from a bunch of 3D printed stuff to robots. Some of my favorite robots are the MicroMouse robots. These are tiny little bots that go through a maze. So they kind of make two passes through the maze. One of them is just finding their way and mapping it out the first time. And then they go all the way back to the start and they do a speed run through it. And it's awesome to watch them. The ones that win the contests are like, if you blink, you're going to miss a lot of the movements. In this case, it's the teeny version of the mouse built by Carrie. This is actually the 5th iteration. And the picture at the top of this, you're going to see the thing right next to a 500 yen coin, which is about 26 millimeters in diameter. That's a €2 coin, or a little bit bigger than a US quarter. And it's kind of like mind-boggling to watch this thing actually work in the video. One of the cool parts of it is they show it on a piece of paper, and you turn the paper on the table and the mouse stays perfectly pointed in the right direction, because the sensors are kind of like doing a way holding for it, which is neat. But there's also a video of these finding their way through the mazes. They do a great job of it. And for me, the construction technique is particularly interesting. It is mostly a circuit board. And so kind of like a panel of circuit board is printed out. There's a big piece that's the body of the MicroMouse itself, but then there are 7 other pieces. 2 of them hold the motor drivers for the tiny, like, quadcopter style brushless motors. And then 5 of them, they stand up like monoliths at right angles to the main board, and they hold the sensors, a time of flight sensor and 4 infrared reflectance sensor, all on the front of the little robot.
Watching these things do speed runs, the speeds that they attain is really incredible. And it's fun to read about Carrie here, who is shrinking them down and finds that there's a considerable gain by getting rid of the fans. And you're saying fans? They used to have fans to suck them down onto the ground so that they could get more traction, so that they could move and corner faster. When you watch these things go, they're just like zip, 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 zip. And you're like, what the heck? But this last one, I agree with you. It's phenomenal, and it's packing so many different sensors into it. It's got a distance sensor out the front and these small short range proximity sensors on the sides on those little cards you were talking about. plus an IMU, plus, plus, plus. I mean, it's really an incredible piece of machinery to all be fitting, like you said, just over the size of a quarter.
Those IR reflectance sensors too have a neat little thing where they're on both sides of the PCB, like the emitters on one side and the receivers on the other. And it uses the shard of PCB itself as the physical separator so that you don't get bleed through from the transmitter to the receiver. So it has to go out and reflect off like a wall of the maze and come back. I'm glad you mentioned the fans. So a different Carrie, so that Carrie is the person who made this, but a different Carrie, the Hackaday writer, picked up in this article, and he said that his favorite was looking at one of the earlier versions. And if you go look at the third version 3 of this robot, it has a little 3D printed impeller that is perched right over a hole in the center of the board. That robot's a little bit bigger, and that is supposed to create the suction underneath the robot that sucks it down to the table. And then for all of these, like on this smallest one that's being featured here, it looks almost like it's a friction drive from the shaft of the motor to the wheel itself, but it's not. There's a tiny little gear that drives a larger gear that's sistered up to the wheel on its axle. And in this third version that has the impeller fan, there's 2 wheels on each side, and you have double of those large gears driven by the single smaller gear from the motors. There's a lot to be learned here. It's all up on GitHub, and boy, I do really want to build one of these now, Elliot.
All right, last up, this one's not really a hack. The Gatwick drone, finally someone who isn't us, asks whether it ever really existed. Jenny reported on this. It was 2 years ago Christmas when the London airport Gatwick was shut down for a couple days because there were drone sightings, apparently. And there was a big hubbub about this. Conspiracy theory people thought it was maybe a wag the dog thing, and it certainly crystallized in England a drone regulation panic that actually ended up in some new legislation there. But before it was all over, some people got arrested and released because they didn't have any evidence about them. The police gathered tons and tons of witnesses and witness reports, and none of them ended up being substantiated or corroborated. And it looks very much like the whole thing may have been not a hoax. My best guess is that it wasn't maliciously claiming there was a drone there when there wasn't, but people saw some lights and said, that must be a drone. Reminds me of nothing more than like the 1950s, 1960s UFO panic in the States where, every crazy light in the sky was the little blue men coming to get you. So it's good, even if it's a couple years later, to see The Guardian, I guess it was, do some investigative journalism on this, try to tie up all the loose ends and find that there actually were nothing but loose ends.
Well, and that Guardian article is long, and they look at it from many different angles. I really appreciate that. It's a wonderful read that's worth checking out. Even if you, like I, have followed Jenny's coverage of this, I should also mention Jenny gave a talk on this at CCC Camp and links to it in this article. But some of the things that I didn't realize is they brought in an anti-drone military unit that has like detection and jamming hardware and couldn't find any drones in the area. They had an interesting story about a professional photographer who is also a drone enthusiast and was, as soon as the news of this broke, was camped out at the end of one of the runways trying to get photos of this, and was one of the eyewitnesses who saw lights and reported it, and then realized shortly after reporting it that those lights were a helicopter hovering something like 10 miles away. The depth of field made it look much smaller than it was actually was, and ended up calling back in and saying, hey, wait, I was wrong about this. Lack of evidence doesn't mean it didn't happen. But at the same time, once you tell people, we think there's a drone flying out somewhere in the dark right now that shut down this airport and we're losing millions of dollars, it's like those motes that are in your eye become drones. and I think it's really easy to have false positives because when you're looking specifically for something, you tend to see it.
And it looks like some of the cases of false positives were actually attributed to things. There was a crane moving around in the far distance again that a lot of people were calling in and reporting as a drone. You mentioned the drone hunters came in. The drone hunters came in with drones. And so people were reporting the police drones back to the police saying, I've seen the drone. And the police are like, yeah, that's our drone. The funniest thing is it looks like it all may have been started by a helicopter off in the distance, and that's the best guess anyone has as to what it was. Yeah, it's tough. When it's nighttime and you see a light, it's hard to tell whether it's a star or a planet or an airplane unless it's moving, right? I do understand that. I think it's kind of a shame to put the burden on the drone flyers. I think what the airports need is significantly better drone detection devices so that they can say, oh, we think we've heard a report of a drone, and they can go and do, for instance, a radio sweep and figure out if there's a drone being commanded in their airspace, and then either confirm it quickly and then shut the airport down, or negatively confirm the sighting and say, yeah, that's not something. And, that way they don't have to cease operations, which costs, millions and millions and millions of dollars for something as busy as Gatwick. The burden here has been put a lot more on the drone flyers, and I think, 99.999, I don't even know how many nines of them, aren't flying around airports. And the burden has not been put as heavily on the airports, who should be the ones figuring out if there's actually a drone there at all, and should have some kind of quick procedure to establish whether there's a risk to aviation or not, and either keep the thing running or shut it down and take care of the problem.
First up on my list of quick hacks this week is no battery pressure sensors for bike tires. And that's tires with a Y because Lewin wrote this one. It is an awesome project by Captain McAllister. I had read on Hackaday a few years ago, and I couldn't find the article for it, a bunch of stuff about contactless sensors. They're like RFID sensors. And this is a great example of one. It's a little stem extender that you would put on a valve on your road bike, and it's been milled out on the side, so a little PCB can be epoxied on there that has the pressure sensor on it. And when you read it with an NFC reader, the antenna on it energizes the microcontroller and sends back the pressure reading. The cool thing about it is, since you don't need a power source for it, Captain McAllister was able to do some injection molding to encase the thing so that you can take it out on the road, and it can be wet, you can get road spray and other grime on it, and it's not going to be a problem. Second up on my list is a teeny chain link fence made with hand cranked brilliance. Lev Shah is the one who built this thing. It's an article written by Danny Conradi, and it looks like chain link fence for ants or for a little model railroad, but really it's a chance to play around with the idea of this manufacturing technique. The mechanism is really interesting because it's like a spiral of wire, except for the spiral has to be flat. And how do you do that? Well, you put a flat piece of metal inside of a tube that has a spiral cut into it. Worth looking at just for the mechanism itself. And finally, Flipbook automation saves your thumb. This article written by Al Williams is on a project by Barquanix. It is basically a split flap display, which I find incredibly interesting, and I'd love to get my hands on one and just haven't had the chance to yet. Now you can take bamboo skewers like you would use for grilling and a bunch of extra cardboard and turn it into a split flap display. In this case, it is motorized, and there's kind of like a flipbook animation that goes along with it. So when you turn it fast enough, you see the sunrise coming up. A clever way to prove a concept, and you could always scale up from here and make it more robust. But if you're just playing around, it's definitely my kind of thing.
All right, my first quick hack is cassette synth plays with speed control. Rich Bennett shot a video of his build of what we've seen a lot of recently, which is a cassette player with variable speed control hacked to make it playable by hooking it up to a bunch of potentiometers and some keys. This is just a nice little build. It's pretty. He's got a lot of attention to detail. And one of the things I loved most was his use of copper tape for the power rails on the inside. So instead of having a bunch of loose ground wires, he lays down a strip of copper tape and solders short wires to that. It's kind of like having a ground plane layer in a PCB, except here he's just taping it down and connecting to it. It's marvelous work. Next up, Cyantan Pal has a slim RGB matrix, which puts the LEDs inside the PCB. This one's really cute. It makes use of the ability to route arbitrary shapes into a PCB. In this case, the WS2812 modules are about as thick as a 1.6 millimeter PCB. He cuts little squares in for each one, and then the back side where the normally surface mount solder connectors are lines up flush with traces on the board, and they all get soldered in. You can't put much other circuitry on this because most of the board is routed away, but it sure does look sleek. And last up, ARM and x86 team up in a no-compromise cyber deck. MSG has built a really cool cyber deck here. It's got 2 computers inside of it. It's got a Raspberry Pi and an Intel i7 NUC. When the NUC is running, the thing's a power hog and you have to plug it in. When the Raspberry Pi's running, you can do it on battery power. Doubling down on the double use, it's got not just an LCD screen, but also an e-paper screen. And I think we were talking about this a month ago, and I said, man, that's going to be the coolest thing for a cyber deck, to have one with an LCD and an e-paper screen. And I'll be damned if it hasn't been done already. So hats off to you, MSG. This is an absolutely beautiful build that makes use of the e-paper to display things like system temperature, time, battery percentage, etc., even when the main LCD screen is powered down, for the ultimate in battery savings.
It's time for our Can't Miss Articles of the Week. This is the long-form content written by excellent Hackaday writers, and I picked one that Lou and Day wrote called Hyperloop Fast, but at What Cost? This is a really interesting topic to me because I think about what Hyperloop actually is, and it is a form of transportation that's like leveling up rail travel. It's going to take a tube that's big enough to put basically a specialized train car inside of it, and it's going to pull that tube down to some level of vacuum so that the air resistance isn't quite as much. It's going to put the passenger vehicle in that tube, and it's going to send it through really, really fast, to the point of which you could make a trip from San Francisco to Los Angeles in like 30 minutes. Which is incredible. But it seems like it's going to be really difficult to do. I mean, a vacuum tube going, 350 miles. Like, how do you get the passengers in and out of the tube? What happens if you need to have an emergency escape at some point along the way? If you think about subway cars, you can stop the subway car and open the doors and people can, make their way along the side of the subway tube, but you're in a vacuum tube and maybe it's underground or maybe it's elevated. Like, there's just a lot of questions there. The biggest one that Lewin looks at kind of ties into that, which is, what's it going to cost to make this happen? And it seems like the originally quoted numbers are going to balloon up quite a bit. Originally thought it was going to cost $6 to $7 billion to build this thing, and that they would be able to charge $20 for a ride, which is incredible. Now, Elliot, I went and looked it up, and you can get a flight right now from Orange County Airport in the greater Los Angeles area to Oakland Airport, which is the Bay Area, for $26 on Spirit. So it's not outlandish that they could do it for $20, but I think that the return on investment is questionable.
I used to work in a cyclotron lab, and this is a big underground vacuum tube. Now, when they do vacuum, they mean real vacuum, right? This is a particle collider. It has to be a super vacuum. These guys are just pulling a little bit of a vacuum so that their train can go kind of fast. But let me tell you, maintaining a vacuum over, and in our case, I think we had like 4 kilometers of loop under the ground. It's really tricky. There are holes that can pop up everywhere. And the idea of running one of these then 350 miles or whatever from LA to San Francisco is going to be a lot trickier just in terms of extent, although I guess they're not trying to pull as heavy a vacuum, and if there's a leak, it doesn't spoil the whole thing and they have to shut the experiment down and repump it.
Right, but the ambient air temperature is everywhere and it really wants to get in and mess up your vacuum.
Oh, yeah. And they're going to have temperature differentials between this part of the tube and that part of the
Right.
tube. And I think the loading and unloading is just going to be like airlocks. That doesn't worry me so much.
But you can have an airlock at one end of a 350-mile tube and at the other, or you're going to have it a bunch of them along the way.
You might want to have airlocks along the way, right?
Right. So you've then got to synchronize the opening and closing of these airlocks so you don't slam into it at, well, if they're going to do it in a half an hour, it's 350 miles. You're going to have to be going
760
miles.
miles an hour.
I'm sorry.
Yeah,
There's just no way.
Yeah, so what's funny about this is their testing track was 500 meters long. So 500 meters is about a third of a mile. And they got these two people in this test vehicle up to 100 miles an hour and back down. So the thing's got a fair bit of grunt. I'm kind of impressed by that. I guess if you're not fighting air resistance, it's not so bad. If you think of that in terms of like quarter mile times at the racetrack, this thing hauled butt. On the other hand, if they're aiming at 8 times that fast, it's quite a different sort of thing. They're going to have a lot more track to get up to that speed in. So, I'll give them that.
Oh, imagine that if it was the average speed. So they ended up going much faster than that.
Yeah, no, top speed.
Yeah. So let's just say they solve that, right? Let's say they, solve the vacuum part of it. The vehicle goes fast, all that stuff. The economics of it that Lewin dips into are really interesting. And I actually crunched some of the numbers a little bit further too. So, he reports that they're planning to have 28 people per car. And they can have a car every 30 seconds. And so that's 3,360 people per hour.
How do they offload a car with 28 people in 30 seconds?
Well,
they must have a bunch of
on the input and output, right? So the thing is, at rush hour, like that doesn't seem like very many people. If you think about the number of planes at rush hour that are taking off from all the different airports and coming in, I think that, that's still going to happen, I guess. But this is just an alternative form of transportation. But even if you went at every 30 seconds for like the high times of the day, which I would say would be like 14 hours in a day, you're going to have airports operating a lot of flights. So you could have the Hyperloop operating a lot of cars. That's about 47,000 passengers. That comes to about 17 million passengers per year, which is 2 million more than kind of they're estimating right now. So that's a pretty close estimate. So then if you're going to look at $20 per ride, that's about 300 million in revenue at their 15 million number, which is about 5% of the lowball cost. And there have been some analysis out there that think that this cost is actually at least an order of magnitude lower than it would end up being.
Aha. So either the Hyperloop lasts for 60 years without any maintenance costs, or they're not making their money back.
So there's a high estimate that they think that it will cost $1,000 per ride. There's something related to the project as well. So a wide range there. You look at things and you wonder how they were ever put in place, right? So train travel, if you only had horse-drawn carriages at the time and you looked and someone said, we want to put a railroad across the entire United States, especially when the center of the United States had very low population levels at the time, did that sound as equally crazy as this sounds?
That definitely sounded as crazy or crazier.
But then I also think that it was moving goods, and this is moving people. And so if you look at the rail systems in the United States right now, the right of way is always for moving stuff, not for moving people. Like the Amtrak trains have to move to the side while the freight trains go by. And so I think that you end up with a multiplier, like the value of shipping goods must be more valuable than the space occupancy of a person. It's a head scratcher through and through on this one, but definitely a fun thought experiment for me.
I have to say, if I can take one of these 750 mile an hour in a vacuum tube rides, I would definitely be willing to cough up more than $20 for it. That'd be pretty rad, right?
Yeah. I mean, like I was in China, I was in Shanghai, and they have a maglev. And I'm like, yes, anything that I need to do to get on that maglev and ride it, I will do. So I think that adventure tourism definitely could get this thing off the ground.
My Can't Miss article this week is Exploring Custom Firmware on Xiaomi Thermometers, written up by Tom Nardi. And this is him going through an awesome hack by Aaron Christoffel. Aaron Christophel's been doing a lot of hacking on cheap consumer gear, including like Fitbit clones and some awesome e-paper displays. And this one's another one. There is a cheap, approximately $4 Xiaomi temperature and humidity sensor. And Aaron Christophel has reverse engineered it to the point where he can load his own software to it. And now you can too. And what's really charming about this is that the hardware is cheap and his software is significantly better than the stuff that Xiaomi ships it with. It changes the way it works over Bluetooth Low Energy, and instead of having to connect to the device, read the value off of it, and then disconnect, which takes a lot of time and is tough on your battery life, instead this has the device itself wake up and send out a BLE advertising packet just once. It spits out its temperature and humidity data, and then whatever device is listening for it should hear it just fine. This is going to increase battery life dramatically. He exposes a bunch of other things in here, like the temperature offset, so you can actually calibrate the thermometer and the humidity. And all of this through an over-the-air flashing tool. So you can just flash it yourself. It's a really sophisticated and slick means of hacking this thing yourself. And of course, all of it is open source and etc. And this is just another one of these cases where if you take some mass market stuff and you use kind of the economies of scale that Xiaomi has in making these to our advantage by writing better firmware for it, you can actually get a better device out in the end.
Yeah, they look pretty good. They have that slick, seamless white bezel case that you would go with, the iDevice era, and a nice little low power LCD in it. I immediately thought of adding this to like your MQTT setup because you could just,
Sure.
If your broker was within range, you could just add a Bluetooth dongle if you didn't have Bluetooth already built into that. And it could just, decide every so often it would listen for these broadcasts that are coming in from the temperature readouts. I don't remember if Tom said it in the article or said it to me directly, but he mentioned hoping that you could find some extra GPIO on it and end up turning it into something that was maybe able to have some control based on temperature, which I thought was interesting. Since it is a segment display, I'm not sure what utility it would have beyond temperature itself. So it is kind of locked into that. What did you think about the security setup for flashing firmware to it? I mean, that's the real meat of this hack, right? Is that Aaron reverse engineered the verification that the device runs on incoming firmware updates.
There's a bunch of different types of people in this world. There are people who worry about incredibly clever people who know how to over-the-air update Bluetooth devices walking into their house and doing that to them. And then there's me. The range on Bluetooth Low Energy is shorter than the range on Wi-Fi. You would really have to come into my backyard where I would have this thing, stationed monitoring the temperature to change the firmware. And once you're willing to maliciously break into my house or my backyard, you can have my damn thermometer. It's the least of my worries at that point.
Well, more thinking that Xiaomi built these without, you don't need to press a button on it to pair with it or anything like that. And so any of these anywhere, no matter what firmware they're running, can be updated without anything other than proximity to the device. But it doesn't do anything, right?
It's a thermometer.
It's a thermometer. So you could make it say boo. Right, it's got 3 digits.
Right,
and you could hack it and make it say boo.
You could make it read bad temperatures, and that would then turn somebody's heater on or off.
It wouldn't, though.
Freeze their house.
No, it wouldn't, because it doesn't control anything.
No, but imagine you had this in your home automation system, and it was telling you what your living room temperature was, and so you kept telling it was 98 degrees Fahrenheit, so it would shut your heater down in the middle of winter, and then your pipes would crack.
Yeah, that would be crazy.
That's totally what all the evil hackers want to do to me. And they're lined up around the block as we speak.
Well, I wouldn't put this in control of my furnace because I'd worry my own software bug would cause it to think it was hot and freeze my pipes.
Is it exposed to the internet? And if the answer to that is no, I'm significantly less worried about the security of the device because the attack surface is then limited to a small neighborhood around me. And I'm very lax with my own Wi-Fi stuff that runs inside my own WPA local network because it doesn't ever contact the outside internet. And so that means the number of people who could possibly hack on it is pretty small. It's limited to the number of people in my neighborhood. And this is, I guess it's BLE, so it's even less than that in a way. Small attack surface, extremely low value target. Meh, I'm going with good enough.
Yeah, I think the general overarching message of this is, hey, more control for people who want it that are using these, and that's a hack I can get behind.
Yeah, that's right. I'm always a little bit miffed by some of the security people when they insist that things be so locked down that even the person who owns it can't get in there and change the firmware. And there is kind of this built-in friction between hackers who want to hack their own device and then the bad hackers who you want to prevent from hacking the device. And I do think something like you said this doesn't have, like a button that lets you upload firmware to it over the air, would be really nice, because that means only the person who's physically got it in their hand can change the firmware on it. I really get a little bit riled up when the security contingent says we have to lock this down and sign all of the firmwares and stuff, and all that does is prevent me from writing a better firmware in there and flashing it myself.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send in. So if you've done something cool or you see something cool, let us know about it. tips@hackaday.com. And until next time,
keep on hacking. Multi-channel.
Is it multi or multi?
Is it router or router?
Multi-ball. It's definitely not router.
What route do you take?
I don't take a route, I take a route.
No, you don't. You take a route?
Yeah, mail route.
Do you drink pop?
I drink soda.
That was a ramble.
Sorry, I have my dubstep crank.
I'm in deep need of some wubs right now myself.
Some wubs.